Alright, let's say we want to determine the function f times g of x and we wanted to graph it, right? So, quick way we can do this is we'd have to find some points on each of these functions, f of x and g of x. I'm going to start with g of x. So one of the easy common points we can see here, the g function will have 0 and 3. So I'm going to look for points that have common x values that I can kind of discern from. Now there's also 1 and 2. Okay. There also looks like 2 and 1. And 3 and 0. Okay. And we can also look at 4 and negative 1. Right? So these ones are pretty straightforward. We don't need a lot of points, right? You can also look on the other way. Let's take a look at a few points on f of x. Okay, this one isn't so clear cut. Some of these points are, so there's negative 5 and 0. Some of these points are kind of in between the squares that you can kind of see. You should also see 0 and 3. This point here is pretty common, so this is like 5 and 6. This point is close, but it doesn't really touch. So I'm just going to look at the points that we can easily identify. All right. So using these points, so we can see that f of x has the points negative 5 and 0. We also see 0 and 3. We also see the point 5 and 6. So I'm just going to find what the equivalent g values are here. So we can basically look at, and I'm going to find the g value at negative 5, but there's an arrowhead there, so can't really tell, right? It should be negative 5 and negative 8. Okay, so negative 5, negative 8. Whoops. Drew the infinity sign. Okay, so what we want to do here is we want to find f times g of x. So if f times g, and if we want to just look at it as points, right, we can look at some common points. So we can do f times f of g of negative 5. So f of g of negative 5 is going to look like f of negative 5 times g of negative 5. So f of negative 5 here is negative 8. G of negative 5 here was, whoops, f of negative 5 was 0. Sorry about that. F of negative 5 is 0. G of negative 5 is negative 8. Right? So f of negative 5 is 0. G of negative 5 is negative 8. And in this case, we get 0. Right? So we get negative 5 and 0 as one of our points. Okay? Let's take a look at another point. So let's say we have another common point. You can notice here there's a 0 and a 0 here. So let's do f g of 0. So we get f of 0 times g of 0. And f of 0 here looks like 3. G of 0 here is also 3. So we get 9. So the point here is 0 and 9. Okay? Let's take a look at another point. Another common point that these guys have is looks like 5 and 6, and we can also look at, whoops, you can also look at 5 and negative 2, right? So this guy has 5 and negative 2. Didn't write that in order, but it's fine. So in this case, if we do f of g of 5, we basically get f of 5 times g of 5. So f of 5 here looks like 6. G of 5 here looks like negative 2. And we basically get negative 12, right? So we get 5 and negative 12. So you can plug all of these points in. You can get some idea. And this probably wouldn't be a linear function, right? The combination of functions, in most cases, this would probably be somewhat of a quadratic, right? And we can understand this if we take a look at g of x. G of x kind of, if you look at rise and run, right? It basically looks like slope of negative 1, right? So let's just use a different color for this. But if you look at g of x, the slope here is negative 1, and you can see that the y-intercept is 3, so g of x should look like negative x plus 3. And if you looked at f of x, right? If you looked at f of x, you can see that the slope here, right, this is 3, and then this is like 5, right, and the y-intercept is, so if you look at rise and run here, you get 3 over 5x, and it's going to be positive, and the y-intercept here is 3, and if you multiply these two, you can see that we should get a quadratic function, right? Like if you did g of f of x, or f of g of x, it should be the same thing, right? Let's do f of g of x. Just keep it consistent. If you do f of g of x, it's just going to be a combination of these two multiplied together. So we have negative x plus 3 times 3 over 5x plus 3. So you can actually see that this would actually become a quadratic function, right? So if you plot some of these points, right, we had negative 5 and 0, 0 and 9, which is going to be on the page, right? 5 and negative 12, which is going to be beyond the page. You know, we're gonna actually see that this would be a quadratic function. So this is how we combine functions together graphically.